In this video, we'll be doing some topics that are on exam 2 and some sample questions to go along with that. We'll be focusing on topics that we've covered since the previous exam, which will be arrays in 1 and 2 dimensions and functions with pass-by value parameters. So let's start off with one-dimensional arrays. You should know how to declare one-dimensional array. All arrays are declared largely in the same way. They start with a data type. So we can have an array of characters, integers, floats, or doubles. They also need a name. And then we give them a size in this set of square brackets here. We'll also use those square brackets to index it later on. As an example, we could make a collection of float values using float for the data type, collection for the name, and then some particular size for the collection. An example question that would go along with that is question 1 over here. It says, which of the following lines of C correctly declares an integer array of size 10? So we want to know which of these options creates an integer array of size 10. We're going to select this one at the bottom. It has the integer data type and 10 for the size. These other options don't have integer as the data type or have the wrong size. Once we have an array, we need to know how to index it. So let's assume we have the same array as before. We can access a particular element, let's say the element at index 2, and give it a specific value by putting the index in those square brackets and assigning it a value. Now the valid index ranges is always from 0 to size minus 1. The valid indices for this collection are from 0 to 9. So 2 is a valid index, and we'd be able to use this anywhere else we had a float value, whether that's in a conditional expression or in a printf or a scanf or in an assignment statement. This next question says, given the integer array declaration showed below, what does vals at index 0 equal? So we have this array called vals that has integers in it, and these initial values. So we need to know which index we're going to. So here's a look at the indices of the vals array, 0 through 3. 3 is in index 0, 2 is in index 1, 5 is in index 2, and 4 is in index 3. So first we'll evaluate this inner part. The value in the array at index 0 is 3. And the value in the array at index 3 is 4. So vals of vals at 0 equals 4. You should also know how to initialize and traverse an array. Now there is an array initialization shortcut, which we showed in this example question, where we can assign an array initial values during the array declaration. But anytime we want to assign values or traverse the array after that, we'll need to use a for loop. We'll want to focus on the valid indices, which usually starts at 0, and going to size minus 1, so strictly less than size. We can then go into the array at the index I and give it an initial value. Question 3 allows us to put all of those pieces together. It says, write a program that will ask the user to enter 5 exam scores and then print the scores from highest to lowest. For example, if they give us these 5 values, then we'll want to print the highest one first, and then the one after that, so on and so forth. In this case, we need to make the full program. So we're going to start with our preprocessor directives. We'll include the standard input and output library. And we'll start the main function, which will have a return statement at the end. We know from the description that we're going to need an array of scores and that there's going to be 5 of them. We'll also need a counter, the highest score, to also determine the ordering of these numbers and to make sure we don't revisit a maximal value after we've already printed it. We're also going to have J and the current index. So we'll go ahead and declare those. And then we'll need a loop that will allow the user to enter their initial values. Now each of these values is an integer, and we'll store it in the ith index of scores to start off with. And then we're ready to start looking for which of them is the highest. And we want to print out 5 scores total. So we're going to start a loop that will run 5 times. And in each iteration, we want to go through the array and find the highest score. So at the beginning of each iteration, I'm going to set max to be the first value in the array. And then I want to traverse the array using a different counter and try to find which of them is the highest. If the value in the jth index is bigger than max, then we should update max with that value. And we'll also want to keep track of which index that value is stored in. To do that, we'll also need to start index in the 0th position. Once we've found the best score, we want to go ahead and print it out. We'll print out max. And then we want to make sure that we don't accidentally find it again. So we're going to go into the scores array at max's index and set it equal to an invalid score value, so that -5 can never be the maximum because all of our other valid scores are between 0 and 100. So that should finish off our for loop. In each iteration, we are traversing the array to find the maximal value, and then we'll print it out, and then we'll remove that value from the list so we don't accidentally find it again. The next question is a tracing question. It says, what is the output of the following program? And it has an array with these initial values, and it also has I and S. So you might find it a good idea to track the contents of the array and other variables on a piece of scratch paper. So this array has 5 elements in it, which means it's of size 5, and has valid indices from 0 to 4. And given these initial values, 8 is in index 0, 2 is in index 1, 3 is in index 2, 4 is in index 3, and 1 is in index 4. So this is our starting point for the array. We also have a value I, and a value S that starts at 0. And our first loop says that I should start at 0 and go to strictly less than 5, incrementing by 1 each time. And for each value of I, accumulate into S the contents of the array. So when I is equal to 0, S receives its current value, which is 0, plus the value in the array at index 0. So we'll go to the array at index 0 and see that there's an 8 there. So we'll add 8 to S. And I will increment to 1. And we'll add the value in the array at index 1 to S. I will increment to 2. And we'll add the value at index 2. The value at index 3, and the value at index 4. Now when I increments to 5, this is no longer less than 5, so we'll conclude that first loop, and S will have this value. We then have this line, that the array at index 0 should be assigned the value that is equal to S minus the value in the array at index 0. So the array at 0 should receive 18 minus the contents of the array at index 0. So the array at index 0 currently has an 8. So the array at index 0 should be assigned the value of 18 minus 8, which is 10. So we'll go to the array at index 0 and put 10 there. And then we're going to start a new loop where I starts at 1. And for each value of I, the array at index I should get the array at index I minus 1's value minus the array at index I's value. So when I is 1, we're going to go to index 1 and assign it the value from the array at index 1 minus 1, which is 0, minus the array at index 1. So we'll get our values from the array. The array at index 0 is equal to 10. The array at index 1 is equal to 2. So the array at index 1 should receive the value 10 minus 2, which is 8. And we'll put that 8 here. And then I will increment to 2. And we'll go to the array at index 2 and give it the value from the array at index 2 minus 1 minus the value in the array at index 2. 2 minus 1 is 1. And the contents of the array at index 1 is 8. And the contents at index 2 is 3. And 8 minus 3 is 5. So we'll go to the array at index 2 and put 5 there. Then I will increment to 3. And we'll repeat this process for I equal to 3. So go to the array at index 3, and assign it the value of the array at index 3 minus 1, which is 2 minus what's in the array at index 3. So in the array at index 2 is 5, and in the array at index 3 is 4. 5 minus 4 is 1. So go to the array at index 3 and put 1 there. Then I will increment to 4, and we'll do a final iteration where I is equal to 4. And we need to assign the array at index 4 the value that is the array at index 4 minus 1, which is 3, minus the array at index 4. So in the array at index 3 is 1, in the array at index 4 is 1, 1 minus 1 is 0. So go to the array at index 4 and put 0 there. Now there's one final loop in this program that traverses the array and prints the contents of the array at each index I. So what we need to put in our output is the contents of the array. So 10, 8, 5, 1, and 0 for the 5 values in the array. From there, we moved on to two-dimensional arrays. We still give a type to our collection and a name, but now we have 2 dimensions, so we need to specify a number of rows and a number of columns. An example question might be, which of the following could be used to represent a display of products? This would represent a physical display like at a grocery store. If each product is identified by an integer product number, there can be 8 products on a shelf, and there are 5 shelves in the display. So this tells us that we need to store integers. There are 8 across each shelf, and there's 5 shelves total. So we need 5 rows with 8 columns in each row. The other options that we have here either don't have the right options of 5 and 8, or they don't have the integer data type. When we go to index a two-dimensional array, we need to give it 2 indices, a row index and a column index. So in this next example, it says, suppose we have the following array declaration and assignment statement. We have int values 5, 2. So it's a two-dimensional array of integers with 5 rows and 2 columns. And we'd like to go to values at 2, 4 and assign it the value 100. But then it says, what error have we created? Well, we'd like to go to the second row and then to the 4th column. Now we do have enough rows, but we don't have enough columns. We can go to the second row, but there's only 2 columns total, so we can't go to the 4th column. We would have to say the column index is out of bounds. The row index is okay, but the column one is not. So one index is out of bounds, not both. And it's totally okay to have more rows than columns. It just depends on what we're trying to store. We typically use a single for loop to traverse a one-dimensional array. So when we're traversing a 2D array, we often use nested for loops, with 1 counter for the row direction and 1 counter for the column direction. So let's suppose we have this two-dimensional integer array from our example with 5 rows and 2 columns. We'll need 2 for loop counters, and we'll choose one of them to go in the row direction, in this case I, and the other one to go in the column direction, in this case J. This will traverse the values array for each row and then across each row to look at each column. Now what we would want to do next depends on the type of problem we're trying to solve. So let's look at the next example. It says write a segment of code that will change all the even numbers of a two-dimensional array to odd numbers. The array is called numbers. We should assume that rows represents the number of rows in the array, and length represents the length of each row. We may also assume that I and j are already declared, so we're just interested in the fragment that traverses the array and modifies the values if it's even. So we're going to set up our for loop. We'll pick I to go in the rows direction, and j to go in the columns direction, which is represented by length. And what we'd like to do at each index is check to see if it's even. So we'll go into the array, which is called numbers, at the ith row and the jth column, and check to see if it's even. It's even if we have no remainder when dividing by 2. And if it's even, we'd like to change it to an odd number. So we'll visit the ith row and the jth column and modify it in some way. Now we're not told how to modify it, so it's really up to us how we would like to make it into not an even number. We can increment it by 1 to send it to an odd number that is 1 more than the current value. But it would also be acceptable just to set it to an odd number, because all we're told is to make sure that it's not even anymore. Our next example is a tracing question. So similar to one-dimensional arrays, I'm going to set up our indices so that we can keep track of which values are in which locations. We declare a two-dimensional array called vals, which has 3 rows and 5 columns. So we'll need 3 rows and 5 columns, starting our counts for each at 0. We have I and j and t. Your t starts at 3. And then we start a for loop. We start I at 0. So I is currently 0. It says go into the array at 0, 4. So go to the 0th row and the 4 column and put t there. So put 3 there because t is equal to 3. Then set j equal to 0. And as long as j is less than 4, go into the array at the ith row and the jth column. So go to 0, 0 and put j plus 1 there. So then j will increment to 1. And we should go to 0, 1 and put j plus 1 there. J will become 2. Let's go to 0, 2 and put j plus 1 there. J will become 3. So go to 0, 3 and put j plus 1 there. J will increment to 4, which is not strictly less than 4. So we'll exit that inner loop and we'll set t equal to t times 2. The current value of t is 3 and times 2 is 6. So t will now have the value 6. We'll go back to the top of the loop and I becomes 1. So go into the array at the 1 row and the 4 column and put t there. So the 1 row, the 4 column, and put t there. And then set j back to 0. Traverse the ith row for j equal to 0 to 3 and put j plus 1 there. And then assign t times 2. So t is currently 6, times 2 is 12. T now has the value 12. I will increment to 2. So go to the 2 row in the 4th column and put t there, put 12 there, and set j back to 0. And since 0 is less than 4, go to the ith row and the jth column and put j plus 1 there. So the ith row, the 2 row, the jth column, the 0th column, put j plus 1. 0 plus 1 is 1. J will increment to 1, so go to 2, 1, and put 2 there. J will become 2, so go to 2, 2, and put 3 there. J will become 3, so go to 2, 3, and put 4 there. And then t receives the value of t times 2. So t will become 24, and I will become 3. which is not strictly less than 3, so we're going to break out of that outer loop. And we encounter the second set of nested for loops, which serves to print out the values of the array. So we're going to come down here to these 3 rows and put the contents of the array there. First row, second row, and the third row. So let's move on to functions, which is the chapter following two-dimensional arrays. Covers a lot of ground, from prototypes, pre and post conditions, the function bodies, and the actual parameters versus formal parameters. So remember, formal parameters are the parameters that are part of the function definition. They're in the prototype and they become the local variables in the function body. Actual parameters are those variables or expressions that we use to call the function. Let's look at some examples. This question says, what is the purpose of the function below? So we have a generic function f. We need to try and figure out what it's doing so we can identify its purpose. Inside the function, we have 2 variables, I and s. And it starts s at 0. Then there's a loop where I runs from 1 to less than or equal to n, where n is our input value. And in each iteration, it adds n to s, and then returns s at the end. So to figure out what it's doing, let's try tracing some relatively small values of n. Let's pretend that we've called the function with n equal to 3. So I will start at 1, and that is less than or equal to n. So we'll add n to s. I will go to 2, which is less than or equal to n, so we'll add n to s again. And then I will go to 3, which is less than or equal to n, so we'll add n to s again. Then I will equal 4, which is not less than or equal to 3, so we'll stop here, and we're going to return 9. So looking at our options, we don't think this is the sum of all the integers less than or equal to n. That would be 1 plus 2 plus 3, so that would be 6. It's probably not an average since there's no division operations. It's probably not a factoring question. So that leaves us with n squared. Now to make sure, let's try another trace. 9 is 3 squared, but let's try another one just to double check. Let's assume we call the function with the value 4, which means n will be equal to 4. I will start at 1, and s will start at 0. And as long as I is less than 4, we'll add 4 to s. Which means we will return 16. And since that is 4 squared, we can be reasonably sure that the purpose of this function is to determine n squared. This is followed by another tracing question, where we'd like to know the output of this program over here that has in main 3 integers a, b, and c. Now remember, C is a compiled language, which means everything starts and ends in the main function. So we're going to start at the beginning of main, and we expect to end at the end of main. So main has these 3 integers declared, a, b, and c, with initial values 4, 1, and 1. We also have a function f, which takes in 3 integer parameters, and also calls them a, b, and c. So remember, while it's possible for formal and actual parameters to have different names, it's also possible for them to have the same name. So in this case, f has a, b, and c, and main has a, b, and c. Our first function call uses expressions as actual parameters. The first value we pass to f is a plus b. So the first parameter in a will receive the value of a plus b, which is 5. The second parameter will receive the value of a plus c, which is also 5. And the third parameter will receive the value of b plus c, which is 2. And this function call transfers control to f. So we will pause the main function and come down here instead. Now f also has a sum variable that is created, and sum is assigned the values of a plus b plus c. So we're going to add up a, b, and c and store the result in sum. And then we're going to check to see if sum is greater than a times b. Well, a times b in f is 25, and 12 is not bigger than 25. So we're going to come down here and return a times c. Now 5 times 2 is 10. So we're going to return 10 to this location. So that means a is assigned the value returned from f, which means a is assigned the value 10. Now it's followed by a print statement. So we're going to print the values of a, b, and c as they currently exist in main, where a is 10, b is 1, and c is 1. Then b will be assigned the value that is returned from f, where f is given parameters a, b, and c in that order. So f will get a, b, and c. We'll get the values from those variables in main. So 10, 1, and 1, the sum of which is still 12. But now if we check a times b, if we do a times b, we'll get 10. And 12 is bigger than that. So we'll return a times b, which is 10. And b will take on that value, b in main. That's followed by our statement. So we'll print the values of a, b, and c as they currently exist. 10, 10, and 1. We then want to assign c a new value. What we have here are some nested function calls. F takes as its parameters the return value of function f when given these parameters, and then a, and then b. So we need to evaluate this inner function call first. We're going to give f the value of c, the value of b, and the value of a in that order, and transfer control to f. So we'll calculate the sum. And we'll check to see if sum is greater than a times b. And since it is, we're going to return a times b. So we're going to return 10, but we're returning it to this location. It's going to become the first parameter of another function call to f. So we're going to put 10 here. The second parameter is a from main, and the third parameter is b from main. And the sum of those three is 30. So we're going to transfer control to a new instance of f, where the sum is 30, which is not greater than a times b. So we're going to return a times c, which is 100. and we're returning that to this location. So C takes on the value that is returned from that function. We then have our final print statement. So we'll print the contents of A, B, and C from main. So we'll print that A is 10, B is 10, and C is 100. Okay, that is it for our exam 2 review. It's all of the topics we've covered since our previous exam, and we've looked at example questions for each of them. So I hope that you're feeling well prepared for exam 2, and if not, please do let me know.